Hello, I'm JW. This time I'm going to have a look at this piece of equipment. This is called an IRS, or Integrated Reception System, sort of thing you'd have in a block of flats or other large building to distribute television signals around the building to all the various places. Now this particular one is broken, which is why we've got it. So we'll have a look at this and a basic overview of how these things actually work and why they're necessary. And we'll also take this apart and see what's inside. This is not going to be a repair video because of course this has already been replaced with a new one, but we'll have a look in it anyway and see what's going on in there. Now this, as I say, is an IRS, as it says on the front here. It's an Integrated Reception System. Fancy name for something which is relatively straightforward in terms of what it actually is doing. Obviously installing these things may be a bit more difficult than that, but we're not doing that in this video. Now what these do, this particular one has its only power supply on the side here. That's just this plastic box here. This just plugs in your normal 230 volt outlet. Some of these have a remote power supply and can actually be powered in whole cascades of these, like having a whole rack of these in a building or whatever, but this is a more self-contained version. And essentially what we've got here on the left side here, we've got various inputs here, and they're all labelled. And have a look at the end there, you see it's those threaded F connectors on the side there. And then we have a considerable number of outputs, a whole pile on the top here, and equally a whole pile on the bottom. This particular one has 24 of them, and you see they are numbered from 1 to 24. Now the top three of these are fairly self-explanatory. We've got UHF, which is for your broadcast television signals. Back in the day that would have been analog television, but this was put in, but of course that's all digital now, referred to as Freeview in the UK. That's just basically if you're on your house, you stick an aerial on the roof, bit of coaxial cable coming down, goes in the back of your TV, tune it in, and there's your horrendous selection of substandard broadcast channels. And then we have a similar thing for radio. We've got FM here, which is the analog variety, and we have DAB, or the digital audio broadcasting, which is the supposed replacement in digital, but in reality both of those are still in use. And for all of those things there, just distributing those is basically a case of the signal comes from the aerial, there's no actual signal sent back to it at all, it's just purely an incoming signal. That signal is then amplified and then just distributed amongst all of the outlets. However, the situation with satellite is somewhat different, and that's what these four here are for, and you see they're actually coloured: yellow, red, green and black. Now if you have a satellite dish in your house, all you're going to end up with is a satellite dish outside, coaxial cable coming from that to your satellite receiver, and that is pretty much that. However, the difference with satellite is that the satellite system is not a passive receiver like the areas are here, which is just signal coming in. The device at the end of the satellite dish arm requires power to operate, and on top of that it also requires other things sending to it, so it can select, in the case of this older type system, one of 4 different types of selection. Basically what we've got here is horizontal and vertical polarization, and we have a high band and a low band as well. Hence there's 4 of these. Now, if you just have a standalone receiver, the receiver just sends an appropriate voltage and a signal tone to the thing on the end of the dish to select which of the 4 it actually wants, and that all happens automatically. You don't actually see any of that. It's all completely transparent. But because of this, it's sending things out, and then various signals are coming back. You can't just take a satellite feed from a dish and then just split it up and hope it's going to work, because of course it won't. Because each receiver that actually connects to the system has to send its own signals to its own individual dish or receiver. Otherwise you'd have 2 receivers sending things to the same place. Bad things obviously would happen. So what this thing does is that you've got a dish which has 4 cables going to it, which are these 4 here, and each one of these is permanently set to one of the 4 choices, in the case of the 4 we've got here. 4 cables come in here, and then what happens inside this box is that your satellite receivers will all connect to these individual connections here. They will send in the appropriate voltage and the appropriate signal tone to select it. This thing will select it and then connect it to one of these at a time. So in terms of the receiver box, it thinks that this is actually just a satellite dish as in normal, but of course in reality it's this box. So it's routing, say, this one to here, and if this box here wanted that one, it's going to route that to that one. And then if this wanted to select this one here, it would switch over to that one. So a whole pile of switching going on inside there, and this is really the only way you can distribute satellite on a large scale. The only other way to do it would be to have a dish which had dozens of cables coming from it, You can get up to 8 if you're going to have one in your house, but 8 of course is not 24, and you can actually get much bigger systems than this. Or, as you've seen in some dreadful buildings where they couldn't be bothered to pay for one of these, you end up with this disease rash of dozens of satellite dishes slapped all over the outside of the building, which looks absolute crap. So this basically means you can have a single dish, and then you can have this, and then it just can feed, in this case, 24 different outlets for theoretically up to 24 different apartments. Now this particular one has a few other choices here. We've actually got these little adjusters here which will actually adjust the gain on each of the various inputs. And it's got these things which are marked long, medium and short, because again this is a fairly old one which doesn't have auto signal levelling or anything. The idea here is the long ones you would connect to flats or apartments which were far away. You connect the medium ones to those which were nearer, and then the short ones to things which are just literally through the wall, hence short cables, medium cables and long cables. A bit of a rubbish solution, but say this is a pretty old unit, so what you would have done at the time. Now in terms of connecting to these, it has these threaded connectors here which are called F connectors, and it's a little plug that just screws on to the connector, so it provides a good mechanical connection, and also electrical, because bearing in mind it's actually sending a voltage out of here and obviously up to the dish or whatever's at the end, and in the case of the outputs, the voltage is coming in from the satellite box or whatever is connected to the end of this thing. Now to undo these, of course, you can go in your fingers or whatever, but there is actually a tool for this, and here it is, just a normal screwdriver end. We'll come back to the thread in a moment, but on the end it has this open thing with a bit on the end. So the idea is that when this is in place, I've just left this one on here for demonstration, then you can take this thing, the whole bit fits over the cable, and then it can go down onto there, and then you can undo it. And of course you can then remove the tool from it, and then it will just obviously undo with the fingers or whatever, and again the same to put it back on there. This particular one is a crimp-on type of plug, so basically there's a tool which goes on it and compresses the sides to secure it on there permanently. That's basically what you'd use if you're going to do any large quantity of these things. There is another type of plug, which is this one. Same idea, it will just thread onto the appropriate connector, but this actually screws onto the cable, so you basically just cut the end of the cable. That coarse thread inside will then just screw onto the cable end, and in theory you can just do it with your fingers, but that's a good way to ruin your fingers, and that's where the end of this thing comes in with this threaded section. So what you do is you actually thread that onto there, and then when you've got the end of your cable you can just stick it at the end of that and then use the whole of this to twist it onto the cable. Actually it's threading on to the required distance. Now this one is actually fairly widely spaced, even though it might not look like it, but it's still handy to have the tool to go in there, so just go in there and then just tighten that up. The end does actually rotate without the cable itself. The little piece there will just revolve separately, but some of these have a double row on these, so, and they're normally just slightly offset, so you're sort of going behind and in front and behind and in front, so this sort of thing pretty much useful. This one is a fairly cheap example, but you can also get ones which are more robust for continuous use, but this one's fine. I don't do a huge lot of this type of thing. Now this one, I think we'll just remove this power lead because we're not going to be wanting that. We shall dispose of that properly. Now, so this is not an in-depth video about how these things actually work or installed. If you would like, we could do another video on that some other time, but one thing that's missing from this particular model, you'll notice that all of these connectors go into this metal plate here on the side, or some kind of metallized whatever, and all those go in the bottom, and all those go in the side. And the problem with these is that if you've got cables here coming off, going to, say, 24 different apartments, possibly in the case of this one, all of these really should be connected together, and they should also be bonded to the main earthing terminal of the installation. Now, a lot of these newer ones have an actual earth terminal on the side here. This doesn't have one, so in this case it would have been necessary to use a separate bar which all of these things went through, and then that would have connected to the bonding for the installation, because of course you don't want stray voltages appearing on these, or certainly between them, and bearing in mind they're going to individual apartments, someone's equipment could be faulty or busted and who knows what, so definitely worth having there. And of course the same thing applies to these. These are going out to a dish, these are going to a TV area or somewhere else, and a radio area or whatever. Again, they all should be bonded together. So new ones generally have the earth tones on it, but this being an older one appears to not have that. And the final point before we wrench this apart is that because there is actually voltage coming out of these, and there's going to be voltage coming in on these ones, you don't generally want to be unplugging and poking about these things when they're turned on, because there is a possibility of damaging these. There's no particular risk of shock on these because, as it states here, the maximum supply current to the LNB, which is the device at the satellite dish, is 18 volts DC, and this can also supply 12 volts for an external amplifier for the terrestrial. But generally you want to turn this whole thing off and then obviously adjust connection things as required. Otherwise, there is that possibility of damage. Now these of course not designed to be taken apart, but we're going to do so anyway. This one is rather brown on the top here, where obviously that power supply has been on for literally years or maybe decades, and I don't know if that may be a possible date code there, 1309, is that 2009 maybe? But anyway, we will never know. Now this doesn't appear to have any obvious screws, so it's going to be a question of prying it open, I think. So what we could do to start with is just try undoing some of the nuts here with our nice tool, because it's the same basic size, so we could undo some of this. And then you see that the nut just threads off of there. These probably have threads on the back as well, so I think we'll just take all of those off and then see where that gets us to. Right, we're back. I've taken off all of the nuts there and all of the washers. There's little circular washers there, so quite a nice pile of them. So this is actually broken, and the breakage was that it powered up perfectly fine and the LEDs came on to indicate it's working. Terrestrial was being passed through to all the outlets perfectly fine, but although the satellite was here, nothing was coming out on any of the outputs for any kind of satellite reception, even though it was still powering the actual dish. For some reason the voltages were there, but on the outputs you put anything in, nothing there, as if it wasn't even connected. So whatever switching device inside here has completely failed. So we're not going to be fixing this because this has been replaced with a new one. Obviously not worth dicking around with this and having something which is potentially unreliable, because if you have a building with a couple of dozen people in it, there's a potential of a couple of dozen complaints when it doesn't work. Now this power supply appears to just clip on. It's just going to be a DC supply there with your red and black for the positive and negative, and the negative apparently just goes to the casement here. Red presumably is the positive going through inside. And I'll say the power supply on this does work, so that is not the problem. I'll just go in there and cut that off. As you see, it's just a pretty ordinary supply. It puts out, well, it doesn't actually say, oh, so it does 18 volts DC, 1200 milliamps, so pretty basic stuff. And say that is working, so whatever the problem is not that. Now this main unit, presumably this end will pry off just like the other end did. It certainly does, so just a plastic lid. And then we have our metal box, which is almost certainly not intended to be opened, but let's have a look here. So, yeah, the front and the back appear to be just folded over, and there's no doubt some little tabs have been crimped in, so that's just a label, and the back is just flat. So I think if we go in from the side, we may have some kind of luck in busting the lid open. Well, that was certainly a lot easier than expected. So there's the circuit board. Those are just the little adjusters for the various inputs. It's just a bit of foam on the back, which you just to press onto this. And then here we have the actual thing itself. Now, does the back come off equally as easily? Yes, it does. Another bit of foam in there, presumably just to rest onto that. And that's pretty much it. So seems the circuit board is sort of captive in there, so we didn't actually have to take off all those nuts anyway, but never mind, we did anyhow. So here's the top side, if you will. This PCB appears to be actually soldered in to these metal pieces on the edge, so that's definitely not coming out of there easily. So we've got our inputs on the left here with the little adjustments to adjust that level. Outputs on the top and bottom, and these individual chips here to appear to control groups of those. This is the power supply coming in on the right here. Another little item here which is only on the inside, so we'll have a look at all this more closely later on. And on the back, not a whole lot going on there. So we see our individual outputs here. The item down the corner there. Got these fingers which presumably just press onto the back panel, and a little tiny extra board here fitted on the top there. That may well be for the terrestrial, as it has a 12-volt output for that, although maybe not. And that's pretty much it. So not a huge amount to see in here, but if we have a look on the top side here in a bit more detail. Now this little bit of circuitry here is basically repeated 12 times. Each one of these does 2 of the individual connections there. So as we can see, you've got the chip in the middle here, and then it does this one and this one. Markings on these chips are incredibly difficult to see, but it's actually an HCF 4555. I'll put a link to the datasheet in the description of the video. But essentially this is what's going to be doing the sort of decoding, and the transistors on each side here will be doing the switching, and of course the same over this side. So it's basically a mirror image. One side and the other side are both the same. You can see our F connectors here, just comes in there, and then we've got a little inductor there, and then just going through looks like diodes on the top there, and again the same for this one. So it's just the same circuitry on both sides. Single package here, probably another transistor, and then we can see that the lines going off here going away to the rest of the system. So we've got 4 of those there, and we also have some going across over that way. And each of the pairs of the 24 inputs are all exactly the same. And as you can see here, it is literally just copy and paste all the way down there, and it's the same over this side as well. Various traces coming across to the centre. And then we've got these other individual components in the middle here, which appear to be transistors, but say size-wise these are absolutely minute. Yeah, there's a finger for reference scale, and the bottom half again, yeah, it's just more of the same. Now over this side of the board here, this is where the power comes in, so it's negative to the case and then positive is what comes to the middle here. We've got a little capacitor there, and then another inductor going down onto the board. And then we have this component here, which unfortunately I can't actually see, but it's basically soldered to the case, so that would be one of the connections. And then there's 2 others with a capacitor next to it, so most likely this is going to be a voltage regulator of some kind. Negative here, and then it's going to be input and output presumably on the other side, and then the capacitor for smoothing there. So it's actually poking through the board, rather clumsily soldered onto the case there. And here is the other side of that, leads just literally folded over and then going through the board and soldered on the other side. There are some markings there, but unfortunately they're mostly obscured by the leads and the board itself, but voltage regulator would seem to be the most likely option. And then you can see here where the actual side metal case is soldered down onto the board. A fair bit of flux residue or whatever remaining on those. Over the other end, this is the inputs, which would come from the actual satellite dish itself, and also the FM and the TV terrestrial, whatever's there. So we've just got these variable resistors on the inputs here, and these are actually multi-turn, so it's not just a case of a single turn like that. They actually do go around a very significant number of times, so no doubt for some sort of fine adjustment on the input. No, let's click when it gets to the bottom of that one. Not a whole lot else on this particular side. There's a few surface mount probably capacitors there, and then this little bit in the corner, this is the LED which indicates that the 12 volt supply to the terrestrial is switched on. That's generally used for an amplifier at the aerial itself, just generally a 12 volt output, and then it just amplifies the signal at the aerial, and then obviously the signal comes back in. On the back, for each of the 24 connections, we have some very small, what are probably capacitors there. Obviously the length of these has been carefully chosen, so they're all presumably the same length. And then we have this single, looks like an inductor, for each of the individual inputs. And as you can see, it is literally just duplicated all the way along until we get to the top here. And then we've got these fingers which are just going to press onto the metal casing on the lid here. They presumably didn't bother on the other side for whatever reason. And then we have this little additional board here, which is obviously a separate item there. Again, this is where the DAB terrestrial and the FM comes in. All we've got on it apparently is just a whole bunch of individual little inductors, and by little I mean very little, because again, finger for scale. Not entirely clear what's going on there, but anyway, there it is. You see there are some markings on there. Basically it's just L for inductor and then the numbers on it, but you'll notice that some of these have some of the coils bent outwards more than others, so this may be some kind of sort of tuning thing, so they can just sort of bend these slightly to obviously set it up as required. As you can see, they're all just basically coils of wire, but some have bits bent in and others do not. So there we go. And the only connection it's got basically just goes straight through to the other side of the board, and same over this side. 4208 might mean 42nd week of 2008, so let's say it's a pretty old design here. So there we have it. Not a huge amount to see inside these. These are relatively expensive items. These are sort of £300–400 each to buy, but in the scheme of supplying, say, up to 20 odd plus apartments here, that's not exactly a huge cost. Certainly a lot less bother than installing 24 individual satellite dishes. And so this one is actually broken. It no longer switches anything to the outputs, but in terms of what's broken, well, we don't really care because it's been replaced. No doubt it's one of the components on here, or possibly that voltage regulator's bust, or who knows what. But anyway, so we're not going to be looking into repairing this. So that's it for this particular video. There is a link in the description, say, to the datasheet of these individual chips here, and also to some photos of this in a higher resolution. But until next time, thanks for watching.